Okay, yeah, thanks a lot for coming today. It's a very big crowd in general. Mostly, I've been doing these talks with a much fewer students actually, so I'm very thankful for all of you to be here. So, yeah, today I'm going to be talking about heterogeneous benchmarking across domains and languages and how we can use this to enable meaningful progress in IR research. So a little bit about myself, although thank you for the introduction. So I kind of did my undergrad back from BITS Goa in 2018. After that, I worked for a year at industry in Bangalore. And after that, I got interested in research when I was doing a research assistantship at TU Darmstadt in Germany. And ever since from there, from Germany, I got kind of involved in research and more becoming curious about why certain things work in, why certain models. I can take the mic. Yeah. No worries. Yeah, okay. So yeah, I got interested in research during my time in Germany. So I was very curious about questions about retrieval systems. I'm pretty sure a lot of you would have seen different sort of retrieval systems in your course, and trying to understand why certain models fail at certain things and why certain models do well at some tasks. So yeah, currently after that, I joined my PhD. So in 2021, I started my PhD at University of Waterloo. Currently, I just started my third year there. And yeah, hopefully if things go well, I should be graduating in 2026. So let's start our talk with a famous quote by British mathematician Lord Kelvin, who says, if you cannot measure it, you cannot improve it. And this is often true if you see any sort of ML domain. These days, all of them are governed by a certain benchmark. So I'm sure all of you would have heard about benchmarks such as the glue task, which was very prominent, or data sets such as quad. So these data sets or such kind of benchmarks actually motivate or lead to the progress in research in developing better and better models. Today's agenda will be more broken into two parts. So the first part, I'll be talking about IR fundamentals, why you should be doing benchmarking, and I'll be talking a little bit about my own research, which is there about the zero-shot paradigm, and talking about model generalization. So the first half of the talk will be more focusing about English models, and which cover different domains such as biomedical or legal or news. In the next half of the talk, I'll be going into more multilingual stuff. So this would mean that I'm trying to make retrieval systems make work in our own languages such as Hindi or Bengali, the languages which I personally speak, and how we can actually make these retrieval models more efficient without using less training data. How can we make them better? So these sort of techniques and models I'll be covering in the second half of the talk. And in case if you have any questions, definitely you can always raise up your hand, and I'll try to locate you and ask you or I'll try to answer my best. So let's start with a little bit of a refresher. I'm sure you all will be going through all of these models, but I just wanted to refresh them for people who are not familiar with the models. So let's start with what is information retrieval. So in information retrieval, typically we have a natural language query, or a keyword-based query. So in this example, as you can see, I ask which football club does Lionel Messi play for? And often you need to find the answer to this question from a corpus, let's say for example Wikipedia, which has millions and millions of documents. So you need to fetch the correct document which can actually answer the question. So this snippet has been taken from Wikipedia, and if you check the part which has been highlighted, so you see Lionel Messi is the captain of the Major League Soccer club Inter Miami currently. Moving on, one of the things which motivated me to work in information retrieval is due to its ubiquitous applications in different domains. So to give you an example, if you look into Twitter, and you want to search for local news which are there based upon some hashtags. So you would use those hashtags to actually search for Twitter and tweets which are most relevant for that particular hashtag. Similarly, there are many different domains, such as like, websites like Facebook, when you're trying to find similar friend suggestions based upon, your friends and things like that. In LinkedIn, you want to search for relevant candidates given a job description. So all these challenges actually involve a retrieval system, and we use retrieval system in our daily lives in many ways. Let's talk about the very most fundamental retrieval system, and I really highly rate it, up to date as well, known as the BM25, also fully known as the best match 25 algorithm. So it's a lexical based search method. So key idea is that it would do a keyword matching between words which are there in your query versus words which are there in the document. So just to show an example, there was a query, when was Stanford University founded? What the BM25 model would do is it will go through all the terms. When was Stanford University founded? And similarly search for these keywords and terms in your corpora, which has multiple documents. So for example, here it is shown a history about Stanford University or Stanford University Wikipedia. And then based upon these query terms, it would actually fetch you back these documents which are most relevant for your input query. So BM25 usually has two parameters. One is the K1 parameter within it, and the other one is the B. Just if you are more curious about that, I can talk about those later in the talk. Next, moving on, what is currently most hot in research is trying to do dense retrieval with a BEIR based architecture. So just to give a very simple intuitive idea about it, these kind of models, what they learn is they map the text directly to an embedding. So you can imagine whatever input text you give. So let's say my name is Nandan Thakur. It will get mapped to a vector, which is most of the time 768 dimensional long, and which will contain the information of where the text is present in this latent or hidden representation space. So if you see this example, so here the query is, you can see there is a CLS token, a token which we usually add, and you have bank account, and there is only attention mapping. So these models are most typically nowadays used as transformer based models, and what they do is you compute the attention only between the words within the query or within the passage. So there is no cross attention. So at runtime, what you would do is you would take passages, you would compute the embeddings for all the passages, you would store them somewhere in a database, and you get a query. You would first compute the embedding for the query, and then using that embedding and across all the embeddings in your passages, you would get a similarity score. And how you would compute the similarity score is usually people would do a dot product based thing, because you have two embeddings, two vectors. You can compute a dot product between those two, or you can either use a Euclidean distance or cosine similarity. So as you can see, the 2D vector space, so this is usually the representation of the BEIR model, where you can see in orange the query is there, and the most similar passage to it would be very close to it, like the blue dot which is there. So that will be the most relevant document which is there nearby the query. Usually how people fine tune or train these BEIR models is, commonly what they do is they give some sort of hard negatives. And how we define a hard negative is that we basically, a hard negative is a passage which is very similar to your query but actually doesn't answer it. But the positive passage would actually answer it. So you'll come up with such training pairs. So in this example, like you have Q1, P1, N1. So this is one training pair. And similarly, you'll have Q2, P2, N2 until QB, PB, NB, which is your batch size. A batch size which you can define while you're training, depending upon the resources you have. And usually what people learn, or the kind of loss functions which they use, most commonly is use cross-entropy loss function. So in cross-entropy loss function, the intuitive idea is that you push the query and the positive passage closer to each other in the embedding space, whereas all the other passages you push away from the query. So that when you're doing inference, the most similar passages to your query are actually nearby its neighborhood. So that's the idea of how you fine-tune the BEIR models. In the top bottom right, you see, so there are many ways you can get negatives. Usually the most common technique is to randomly, take some passages from your corpora. So this technique is usually known as in-batch negatives. However, you can use any existing methods to give you negatives, such as if you use BM25, you can get the most similar documents, the top passages for your query, and the one which is not the positive one, automatically the others become negatives. So all of these different techniques to actually get negatives. An extension of the BEIR model, which you'll prominently see these days, also is known as the late interaction model. So the idea remains the same, is just that earlier for the complete text, you would have a single embedding. Now, instead of the complete text, for each token, so for example, my name is Nandan Thakur, so I have 5 words, and for each word, there is an embedding. So this sort of models are known as the late interaction model. So they have an embedding which is there for each and individual token. And how they basically do search in late interaction models is, first what they would do is they would do some sort of a token retrieval. So in the example, if you can see, you have query tokens which are denoted by the yellow dots. So for these yellow dots, you are trying to find the most similar tokens in your documents which are relevant to the query. So those has been highlighted with dark blue. So these tokens are found for your query tokens. And then once you have first done this step of token retrieval, next step is actually to do gathering. So gathering is not but another fancy word of you got some blue tokens. Now you want to see in what all blue tokens are actually, which documents contain these. So for example, my name is Nandan Thakur. So Nandan Thakur will be 2 tokens which will be present within a set of list of documents. May not be in a lot of documents. I'm sure like maybe Cristiano Ronaldo or Lionel Messi will be present in much more documents than my own name. So what it will do is it will gather the documents which mentions my name. And once you have gotten these documents, then it will compute the final score. And how you would compute the final score is they do the final scoring using a technique known as maximum similarity. So you will take all the tokens from the query, you will run it through the tokens in your document and then get a final score for each document. So this is another type of a retrieval model known as late interaction model. Lastly, there is finally a model known as cross-encoders. So these are more typically used at the re-ranking stage. The reason for this is so these models don't compute an embedding for an individual text. So what they will do is you will train it in a similar fashion of how you will train a classification based model. So you would give the query and the passage both together as an input to the model. And then the model will predict just a similarity number. So for example, let's say my name is Nandan and I research on information retrieval. So based upon these 2 words, I'll get a similarity score, let's say which is 0.8 because these both statements are kind of similar. And using that score, what you can do is you can find out which passage is actually relevant or which passage is relevant to your input query. So cross-encoders compute, like its name says, cross-attention, like it will see both the query and the passage together. However, it's very powerful in general, but it's quite inefficient because you'll have to give both the query and the passage together. And to make these comparisons, it's cumbersome actually. Yeah. So moving on now, let's talk a little bit about information retrieval benchmarking. First is what is benchmarking and why is it useful? So always remember, typically benchmarks will have 3 crucial components. First is it will always have either one or multiple datasets. Second is it will have one or multiple associated metrics to evaluate it. And the third is you would need to know a technique to aggregate performances. So these 3 are usually you will find in any benchmark which is out there. There are certain advantages of benchmarking. So first advantage of benchmarking is it gives you a united platform, and which is useful in understanding fundamental gaps. So unless you actually, someone comes up and tells you that, I have this model which does really well, but then you ask, okay, how do you know it does so well? So then he would say, okay, I tried it on this benchmark and it gave me this X performance. So if you already know about the benchmark and if you know it's a very reliable benchmark, then you can say, yeah, okay, it gets the X performance, which is more than my model, which I got on the same benchmark. So I know it might be doing something better. So benchmarks are kind of really good, and they give you a unified platform to evaluate your models on a fair ground. After that, let's say what you can also discover is state-of-the-art models. So a lot of times you will find every benchmark will have a leaderboard, and people would be competing to try to get the best performances on that. So for in order to recognize the state of the art, a benchmark is very useful, because you will get to know what kind of models are currently present in research, and where does your model, which model you will propose, how does that fare in comparison to previous ones. Finally, it also sets a standard, so you can check or use your benchmark to basically set a standard, or use it to compare, saying that your model is better than someone else's model. So benchmarking in IR is actually not a new thing. So it has been there since 30 years old actually. So as early as 1992, people have been starting to benchmarking different models, and it's very, like, originally also the benchmarking culture has been traditionally present within the whole IR community. So ever since 1992, they have been coming up with this, you can imagine these trek tasks, which are shared tasks which happen over the year. And they would basically give out a test collection, which they will have annotators annotate it, come up with a collection, and then use it and actively, gather participants so that they can participate on their collection. So this way they actually benchmark the models, and as you can see, in Trek, they cover many different domains. So they cover personal documents, retrieval in a domain. They also have some which go even beyond text, like OCR-based things. So that's why, like, Trek kind of has been traditionally doing it ever since, from 1992. So if I look into, some of the more recent models and how do they perform on some standard benchmarks. So what you would find is, typically the BEIR models, which I talked about, so they're also known as the dense model because it maps to a dense vector. So you would see that these models, in comparison to the BM25 model, they're actually doing pretty well. So if they are typically evaluated on either NQ or MS-MIRACL. So these are two very common data sets which are used in IR evaluation. And there are different metrics, but overall you can find that, the DPR model, one of the BEIR models, they actually outperform BM25 by 20.3 points. And similarly, you have these other models which outperforms on, let's say, 9 points. But here, there are some caveats which, oh yeah, there was a question.
So as you discussed that we sort of compare different models on a certain benchmark. So benchmark is being used to compare the models. But if we have multiple benchmarks, how do we compare them among themselves? Means which benchmark is good, which is bad?
Good question. So I'll be coming to that one. So so that's one of my points actually.
Okay, thank you.
Yeah. So yeah, let me continue from here. So you'll often see models are outperforming certain other models on a few data sets. And what they will say you is they don't actually tell you these caveats. So one caveat is actually data sets such as MS-MIRACL and NQ, they contain over 100K training pairs, which is not common because they have an insanely large training data set, which really helps train these dense models or these neural models, which are very data hungry. And what it doesn't reveal is any insights about model generalization. So how would you know if a model performs on this data set, MS Marco, and I just told you it's a good data set, but how would you know whether that model is going to perform well for your own task? Maybe let's say if you want to use it as a pharmacist who wants to suggest medicines given a particular fever or cold or flu. So you don't know whether these models will actually perform on a different domain where it doesn't know the knowledge. And the another interesting part is, it's a very interesting question, is you don't know whether the improvements are actually just due to overfitting on training data set. Maybe the model overfits on the training data set and it gets a really good performance on this particular training data set, but it doesn't generalize to other data sets. So in order to tackle these sort of questions, so let's see another data set, such as the common one, which is MS Marco. And there is an interesting plot which I made. Actually, I compared the maximum performance of the model across the years. So MS Marco as a data set was introduced in 2019, and I have made the plot until 2022, and I have plotted the maximum performance, like the maximum model performance. So do you see a trend which is there in the graph? Anyone?
Improvement is getting much lesser.
Exactly. You're correct. Exactly. So if you can see, like, by 2020, actually models got 0.4 to 9. And ever since the past 3 years, even currently also, the maximum it has got is 0.45, and currently it's 0.455. Now, do you think it's a good enough? If let's say I make a model today and I say that I got 0.451 on MS Marco, do you think that's a good contribution in terms of research? No, right? Because it's just a 0.1 point improvement. But this was actually an issue which was happening in research. People were only focusing on evaluating models on one data set. They would get a minimal improvement such as 0.1 point, and they would claim their model to be state of the art. So this was an active issue, and the issue was because you were only evaluating on a single data set. Another interesting part was, originally how these data sets were constructed is you have some sort of judgments which humans do, and based upon these humans or goal labels, you actually evaluate models' performances. So in a study which was there in this paper, I'll share the link later, what they took is they first gave some human annotators the original goal labels, and they also gave some human annotators the passages which were ranked by the model. So actually the annotators preferred the model more than the original gold. So you can see that the whole labeling process, it's actually very personal. So what you may think is a correct list or the most relevant list of documents, I may not agree to it. I might have a different choice. But my whole point is that the data set is kind of saturated because whatever it is being trained on, and if it gets a 0.1 improvement, it's probably just due to the bias which is there present in the data set. So what we've kind of proposed in one of our benchmarks is we actually propose a zero-shot evaluation. And why we want to do zero-shot evaluation is, first is that we have typically a lot of unlabeled data. So unlabeled data you would have in millions, because if you take any web corpus, you would have a lot of texts. Like if you go to a news website, you'll have a lot of news documents in different articles in different languages. So getting unlabeled corpus is not usually an issue. The issue is when you have to actually create training data. So if you have to create training data, what you would need to do is you would need to first come up with an annotator. So you need to find or hire someone. That person will have to go through these queries and these passages. Probably, let's say he or she can do 1,000 in a day. So, and then you'll have to do this, you'll have to generate at least 100,000 pairs. So you can imagine how cumbersome this effort is going to be. It's going to take a lot of time. It's going to be expensive. And even after that, you'll probably be able to get about 100,000 training pairs. However, if you just need test collections, so these are also quite feasible because you don't need actually to build a test corpora, you don't need thousands of pairs, you just need 100 pairs or maybe at max 100 to 500 pairs. And these can be annotated by annotators, so you don't need many human annotators to actually build such a test corpora. So let me move now to the zero-shot paradigm. Let me talk about IR generalization. So the research question, what we try to see is whether modern search systems will generalize. So what typically has been there is you will have a BEIR model or these different models which I talked about. So they are usually fine-tuned or trained on a certain data set or a certain domain. For example, Wikipedia, if I take as an example, and then they are evaluated on the same domain itself. So they are evaluated on Wikipedia back, and on these cases, actually the model does perform really well, so it can answer any question you have. But what we want to evaluate actually is domains without any sort of training data. So you have these models which are fine-tuned on Wikipedia, but actually now I want to see how well does this model evaluate if I go and try to search something about COVID-19, whether, during the pandemic, whether I should wear masks or not, or something similar, in Amazon, where you're trying to find recommendations for, purchasing some items. So do these retrieval models work well for different domains? So in order to come up with this question and in order to solve this, what we led to a creation known as the BEIR benchmark. So the BEIR benchmark is a zero-shot IR benchmark, which contains 18 different data sets. And what we focused in BEIR benchmark is we tried to include as much as diverse tasks as possible. So if you see, some of these data sets has like tweet retrieval. So given a news header, we actually want to retrieve relevant tweets for it. There are also other data sets such as you have Quora. So whether you want to detect duplicate questions which are being asked in Quora. And similarly, we include a lot of biomedical data sets as well. So our whole focus is, given these benchmark which contains many diverse data sets, how well does a model perform on it? So what we see is kind of surprising, and we found this insight from our paper, is that, so this table or this figure basically shows on how many data sets does a model outperform BM25. So what you should see is like typical or very popular dense retrieval models or neural models at that time, such as TASP, GenQ, ANSI. These are all different names and different research works. So they all would actually cannot beat a BM25, which has been there since 1990s, a very simple algorithm on different domains. So this was very surprising because everyone would claim their model to be state of the art, but actually when you would evaluate it on a different domain, then you would find that the model doesn't perform so well because it's not been trained for it. So this was overall our the trend which we found in different models, like the generalization performance. Like the generalization typically means how well does a model perform out of box on a domain which the model has not seen. So how well does the model generalize to different domains? Yeah, so the question is like, why do these models actually suffer in generalization? So there might be many actually reasons for why, but for one of them, what we will focus on is actually the domain specific vocabulary is not known. So to give you an example, like COVID-19 was actually introduced in 2019, and all of these models are mostly derivatives of BERT and transformer-based models, which had seen training data only up till 2018. So the model doesn't know what COVID-19 is. And let's say if you have a corpora which talks about COVID-19, how do you actually teach the model to know what COVID-19 is? So these are some of the cases why the model fails, because it doesn't understand where to map the particular word of COVID-19 in your embedding space. So yeah, like I mentioned, unknown words, how do bioencoders handle these unknown words which are unseen during fine tuning? Like I said, so another thing could be like new words and concepts. So new words, RAG is a new word which got introduced like, much recently. Or ChatGPT is a word which got recently introduced in about probably, let's say 2021. So how would the model know? Because the model dates from 2018. Where should it probably put ChatGPT? Any guesses? Okay, yeah, so just a very simple thought of my head, it should probably put it very close to large language model because it's probably one of the large language models. And these are some ways how you can actually teach the model to initialize certain words or certain new words which has not been seen before. Yep. Okay, so let's talk about one of the techniques which we actually looked into to do unsupervised domain adaptation. So unsupervised domain adaptation is one of the techniques how you can actually improve model performances on different domains. And we found this technique to be really helpful. So unsupervised domain adaptation and our technique known as GPL has three components. First component, what you would do is you have unlabeled text, right? So you have a corpus, for example, let's take COVID-19 documents, research articles which are talking about COVID-19 and its spread. So you have these articles. What you would do is you will actually first generate some questions. You can use any model. Nowadays, people might even use ChatGPT. So you can use any sort of a model to generate some certain questions for each and every passage in your corpora. Next, what you would do is you would do a negative mining. So remember in the beginning I talked about dense retrieval and how you need triplets like a positive, a negative, which was highlighted in red. So in our case also, since I generated the query, I need to also find a technique how to mine such hard negatives. So typically you can use any sort of a model or an algorithm to get the hard negatives. Like people might use some predefined models like, you can use BM25 as a very simple example. But using the negative mining, you get triplets. You get a query, the original passage from which the question was generated. So that becomes a positive one. And then you also have negatives. And the third is, the crucial component is what we do is pseudo-labeling. So pseudo-labeling is a way we try to distill some information via the cross-encoder. So as I mentioned before, cross-encoder takes the query and the passage together and gives you a score, which was the classification-based model. Yeah, so what it would do is, so you have the query, what is Python, and the positive passage is Python is blah, blah, blah. Probably Python is a programming language. So this both are similar. So that's why a cross-encoder gives a score of 10.3 because they both are similar, talking both about Python. You might have negatives such as Java is also a programming language. C++ is also a programming language. But all of those are not actually answering what is Python. So those become negatives in your case. And typically we are kind of creating these sort of synthetic pairs ourselves using this technique. So just to show some results, what we kind of evaluate these GPL based models is we benchmark it against the previous state of the art. So as you can see, the GPL model, it gets on 6 data sets on BEIR we evaluated. These scores actually denote a metric known as NDCG at 10. So on GPL gets 51.5, and previously if you actually take the model and which is the above one, zero shot TASB, so that only gets 45.2. So the model which has not been seeing all of these domains can only get a performance of 45.2. BM25 gets 48.5. So you can still see BM25 beats the the original model. But now with our technique, we are able to beat also BM25. Yeah, and also what we see is that it's not like, if you keep on giving training data, the model will keep on improving. So there is always a saturation point after which the models stop to improve. So we found in our experiments, usually this was after 120K training steps. After that, if you see the graph, it kind of saturates, and more than that, it probably won't improve much. Okay, and yeah, the main reason for GPL success is what we find is that, yeah, I'll probably skip the slide. I'll come back later if I have time. So now let's go to the second part. Yeah. Okay, yeah, if anyone has any questions, yeah, yeah.
Just give my view. So, just let you know, as probably I mentioned in my earlier lectures, anything which has been covered in the class part of your examination, right? So just be clear, pay attention. I'm sure all of you are already paying attention, but anything which has been covered in the class is part of the syllabus. Okay, first thing. Second thing, students has already scored the bonus thing, which is usually the case. So feel free to ask questions. Okay?
Yeah.
So I had a couple of questions about the negative generation.
Yep.
Like negative mind. So, like for example, in this case, I'm assuming the document which has Java in it
Yep.
has been determined as a negative mind, right?
Yes.
Has that been done through some labeling, or is it being sort of hard coded in some way? Like the model learning that Python and Java are hard negatives. In some way, how is that being done?
Yeah, so how we are teaching the model as a negative is based upon this score. So you have a positive and the query, which it was like, the query was generated from the positive passage. So as you can see, it gets a score of 10.3. So this would mean that, this passage is very relevant to your query. Whatever is not as of this score, this would be a negative. But this is not a hard-coded thing. So this is something we are actually teaching the model. So it could be likely that you might get a negative which has even a higher score. But the model then will teach the opposite. So then the model will teach that this negative passage is actually more relevant than your positive.
So for the hard negative, is there a threshold, or you just take the maximum score? Like you get 10.3 here, so that's your
Yeah.
best case.
Yeah, I think so. I kind of skipped that slide. So, probably good to go through that one. So if you check the margin MSE loss function, so that's the one which we typically use. To give a very intuitive explanation of it, what we do is we subtract both the scores. So 10.3 minus 8.2, which will be about 2.1, and this 2.1 margin we give, or we make the model learn the margin. So the more the margin is, the model will actually learn the negative is an easier one. But if the margins can also go in negative, what if your negative is more similar to your query than the positive? So then the model also learns that because you give the negative score to the model.
And just one last question about
Yeah.
the evaluation metrics.
Yeah.
So are we reporting any standard NLP metrics there, or is it some other metric?
Yeah.
The average, which is there, we use like this.
Yeah, so we typically in IR based benchmarks, you would see metrics such as NDCG at 10, MRR at 10. So both have different meanings. So usually when someone reports NDCG at 10, in a very intuitively described way, if I have to explain it, what they evaluate is the ranking of the top 10 documents. So imagine you're on Google search, you see top 10 results, and you obviously want to see your top result on the first line, right? Somewhere on the above. So that's what the metric calculates, which passage is ranked where in your top 10 list. So that's commonly what we use, and also known as NDCG at 10.
In that, the ground truth which you're calculating against is the correct ranking?
Yes. So ground truth is basically imagining that you would have all the correct ranking scores and all of them are on the top.
Thank you.
Yeah, no worries. Thank you for your question. Yeah, anyone else? Yeah, I have one hand here.
Should
Yeah.
we not change the baseline from BM25 to BEIR encoders? Like BEIR encoders outperform BM25, like you said. So should we not change the baseline from it? Like we have to take biencoders as a baseline for new models that will come.
Yeah, exactly. So here we also included, oh, let me get to that slide. Yeah, so here you are correct. So what we actually take as the baseline is the bioencoder model, which is TASB in this case. So and our baseline is to actually beat that, because that is a zero-shot model which has not been further fine-tuned. But what we propose is a way you can actually domain adapt your model on a certain domain. For example, it will actually generate some queries about COVID-19, and we will use then these training pairs to train the model further, and then that model we find is once you give such kind of a training data, it outperforms the original model. Okay, anyone else? Yeah. Mic is there. Oh,
Yeah,
sorry.
basically,
Yeah.
whenever you are mentioning the hard negative, so is it contemplating the whole context or just the token only? Like, suppose an example of Python, it can be asked from some other perspective, like Python is also considered as an animal. So rather than a programming language, it will consider that document too. So will you be considering that token only, or the context is also taken into consideration?
Yeah, the whole context is taken into consideration. But that is a good question actually. So in this case, actually what is Python? The Python animal can also be relevant because you don't know from what context the question was being asked. So if the question instead of what is Python was asked whether is Python the best programming language, in this case the Python animal becomes a negative. But actually with just what is Python, like the animal Python is also relevant. But we are considering the whole context because all these models actually transformer based models. So they typically see the whole context, not just the word itself and the surrounding context around them as well.
And whenever we are searching for a query, suppose we are just turning around and searching some other, the programming language which has been used for training machine learning topics. So the ranked results could maintain the Python, then Java, and any other programming language. So does that metric keep that into consideration?
Yes, it will. So if let's say you have all three of them to be relevant, it doesn't matter in what positions they come. What really matters is in your evaluation where, so NDCG at 10 will probably try to optimize in a way that you get all the relevant results as on top as possible. But there are other metrics like MRR. MRR, what it does is it only checks where the first result is there. So if your first result is on the top place, so then you'll get an MRR of 1.
So while considering that some basic queries are there, and if I want to just substantiate that I want to use some other to check for the results, like that is not even the part of it. But still I want to mark that my R system is working fine with respect to that particular query. So how I would differentiate? Like my result don't get ranked to that particular negative query, which shouldn't be the part of it. Like I just want to measure the accuracy of it, the precision of it.
Okay, so how typically, yeah, probably I didn't cover that, but how, I think so, if I understood correctly, what you're trying to understand or what you're trying to ask is how do we create a collection, like a test for this particular query. So you would use a human to do it. So what you would give the human is for that query, you would give him a list of let's say 50 results. And that human will go through each of them and mark whether it's, okay, Python, ask something about Python. This one is relevant and mark that as either 1 or 2, like depending upon what score you give. So you can give 0, 1, 2 or even 0, 1 to 5. So there are different levels. And then you would do that for all the 50 documents. And once you have that, now you can evaluate. So out of these documents which you evaluated, how many of them which have a score 2 have come in your top 10 list when you actually search for it? And that's how you evaluate or you get a number for it. So for example, if all of them are relevant, like all of them, your top 10, all of them get a score of 2, so then it will probably get an NDCG of 10 of 1. If none of them are present, it will get a 0. So on and so forth. So I can share some links later on the metrics. So it will be, or some blog posts which explains the algorithm in a very much more intuitive way. So maybe that can be helpful. Okay. Yeah, one question was there. I think so. Last year. Yeah, I think so. It's switched on now. Yeah.
So I want to ask one question related to it. I want to generate this pseudo heavy.
Okay.
So
Yeah.
could you please explain that how it can be more helpful in improving the model performance?
Sorry, could you repeat that? How can it be more helpful?
In improving the performance of the models as you
Okay.
stated.
Okay, so yeah, just to give you an example for that, imagine replace everything from Python here to COVID-19. So what you do is now, earlier the model didn't know anything about COVID-19, but now you're explicitly teaching it, training, giving it that, okay, COVID-19, or let's say whether do masks help protect against COVID-19 or SARS-CoV-2 virus. And then you have some positive passage which would say, yeah, research claims that wearing masks actually help prevent spread of COVID-19. And then you also will have some negatives maybe which doesn't talk about COVID-19, which talks about maybe like, for example, dengue or maybe just cold and cough. So that becomes a negative because it's not talking about COVID-19. So when you give such kind of, when you're constructing such kind of training data and you're training your model further on these sort of training pairs, it actually learns these kind of words and where to put them in the embedding space. So that's why the model now is much better for your own domain.
Okay, so whatever is a positive space, so it will put it into the one side and the negative it will.
Yeah, that's sort of the intuitive idea. So it will push always all these models, they try to push the positive passage closer to the query and push away all the negatives away from it in the embedding space in a very intuitive way. That's what contrastive learning does.
Okay.
Okay, thank you. Anyone else? Okay, one, yeah, last. Yeah, you can say it like that.
Why are we even trying to adapt a model which is trained on a specific domain for another domain? Like, why not retrain another model for another domain? Is that less efficient somehow?
Yeah, so that's a good question. So why we want to do domain adaptation is because if you directly train a model on this domain, it doesn't, first you need to teach the model how to retrieve. And that is usually done with a huge data set like MS Marco. So it really learns how to retrieve stuff, what is search. After that, we do a more of a domain adaptation step to make it understand some keywords which are coming from a domain. So that's why it's typically used after that, although you can start from scratch also. But my intuitive explanation would be it won't work so well because it needs a lot of training data in order to understand how to retrieve first. Okay. Yeah, so let's now move on to the second part of the talk, which most talks about languages. So this is a slide which I really like. This slide starts with information access is actually a right for everyone. So this means that not only you need to speak English actually to search for information. So ideally there are about so many speakers in the world which do not speak English or which have a native language which is away from English. And you would mostly commonly see in Google search also, I'm guessing most of you search in English. So how many of you actually ever searched in a language which is not English in Google? Okay, may I ask which languages?
Hindi.
Hindi, okay. And did you see whether the search results were good or not? Good? Yeah, so maybe they're improving now, but usually this is one of the research cases which we want to go or which we want to tackle. Right now we're only searching in Hindi, but like let's say even I speak Bengali and Hindi, but I never search the Google search actually in Bengali. I would mostly do it in English. And a reason for that is the amount of digital data which is present in Bengali or for Hindi is actually much less. So whatever question you are searching for, maybe the answer you'll find in English, but you may not find it in Hindi or in Bengali. So that's the main reason why you would always search in English. And this is an issue, and this is one of the reasons why currently the multilingual retrieval systems or models which work on different languages don't perform so well. So in order to actually improve multilingual benchmarking, we actually come up with a data set which is known as the MIRACL data set. and we specifically focus on a monolingual retrieval task. So what a monolingual retrieval task means is that you have both the query and the passage in the same language. So for example, in the given case, you have the query in Thai and the passages are also in Thai. They just have been translated in English just to show you. But in this example, what you would do is you have the query in Thai which asks about when was the Final Fantasy game released, and you would then search for passages in Thai which actually answers this question. So we created this sort of a benchmark and we call it the MIRACL benchmark. And there are a few things which you should actually note, which I have highlighted here. So first is we cover 18 languages, which is quite decent actually. And the other thing is that all our queries and human labels, so they were done by humans. So we had actually hired more than 40 annotators to generate questions, and all of them were native speakers of the language. And we hired them, we had done all the generation of the query with them and also the annotations with them. So you can see that what we gathered here, 726,000, is the amount of annotations we gathered, and which is a huge number. And these denote the total number of labels, and we, like I mentioned, so we did this with more than 40 native speakers. And also the last thing which you should notice is MIRACL also gives you training pairs. So which is really useful if, let's say, someone wants to develop a multilingual system after that, or a retrieval system in different languages. So here's the language coverage in MIRACL. So we cover a lot of languages all around the world. So we have, like, let's say, some really low resource languages in Africa, such as Yoruba and Swahili. So those languages are also included there in MIRACL. In India, we do cover like Hindi, Telugu and Bengali. So these three languages we are covering from India. And as well as we have all the other languages, for example, German, Japanese, Korean, Finnish, Indonesian. So we have a wide variety of languages actually covered in MIRACL. So to construct MIRACL, we did two things. So it happened in two phases. So first phase is, what we do is we give the annotator a prompt. So a prompt is like, show them 100 words of a text. And we ask them, based upon this text, you generate a question. So for example, if you ask, or if you give me a prompt about, let's say, IIT, like IIIT-Delhi, for example. So I would ask a question like, so what is, or yeah, maybe I cannot think of anything, or what are one of the most prestigious institutes in Delhi? So let's say I ask this question. So this is sort of a question which I would generate given the prompt which I was shown about IIIT-Delhi. So this question I take, and what I do is I pass it through a retrieval system, so a search system. And again, like I mentioned, how we mine negatives, we would do in the same way. We would get some passages for this particular query. And so now what we have is, we have the query which the annotator generated, and then we have a list of passages along with that. And in the next phase, what the annotator do is they actually label each of these passages by looking at whether the passage answers the question or not. So if the passage answers the question, the annotator will label it as 1, being relevant. If the passage doesn't answer the question, the annotator will label it as 0. So this is how we construct these data sets in different languages. So, my example was in English, but you can do the same thing in any language. So there are certain challenges which we faced in MIRACL construction, but I would just skip through this for the interest of time. So yeah, a question for this. You can say it out. Yeah.
You said that MIRACL have covered like Hindi.
Yeah.
So basically, the Hindi is like pure Hindi, or like it can be like something like that we used to speak in like roads or something like streets. Like, is it like only purest form of it, or like it kind of mixed like?
I see. Yeah, so what we cover is actually I would call it a more of a formal form of Hindi because our corpora comes from Wikipedia, and in Wikipedia mostly it's written in a very formal way, words which even I won't know because they're very formal words available there. So that's the thing, and they're all written in the original Devanagari script basically.
So, are there any researchers who are progressing towards this also? Like,
Yeah, so this is an active research area, although I do not personally work in it, but it's known as, also many researchers look into code mixing. So a lot of times if you type, we actually type both in Hindi and English, so it's known as English. So there are models which are currently being developed which try to actively understand English, because both are actually words in different languages, but when we read it, we understand because our brain processes the Hindi words and attaches them with the English words. However, models are not trained with English. Models have Hindi separate and English separate. So there are also active research which goes on English as well. Okay, thank you. Yeah, so let's now move on to the final part of the talk, which is more about data efficient multilingual retrieval. So an issue which you would imagine what happened previously with MIRACL was, we had collected about 750K training data. But this was done by a 40 plus annotators, which me and one of my other colleague was managing. So it took us more than 4 to 5 months actually to construct the data. And overall it costed us about 450K thousand USD. So you can imagine, first is very expensive. Second is I was working 4 months exclusively on this, maintaining who has done what sort of progress and trying to hire all of them, have job interviews for them. So it's basically a very cumbersome effort. So what I wanted to see was, or what I wanted to research was, how to make, whether can we generate training data without any humans actually for different multilingual things or for different languages. So this motivated us to my research question after that, whether what we want to do is we do prompting techniques with actually large language models. So what we would do is we, instead of asking the annotator or a human to generate a question, we would actually give the model to something like a ChatGPT and ask ChatGPT to generate a question. And we found, like, in this way it becomes much cheaper, because if you want to hire an annotator, that annotator can do mistakes. Annotator is slow, maybe you will generate one question in about a minute, but ChatGPT can generate literally probably 60 questions or maybe 20-30 questions in a minute. So this was much faster, much cheaper, and was an efficient way to actually generate a lot of training pairs and in different languages. So we involved this technique, and yeah, I'll not get into the details of it, but yeah, if you're interested, you can ask me later. So like I mentioned, some advantages of using LLMs was, first was it was a cost-effective alternative to expensive human-labeled training data. Second, it contained a language-specific topic diversity over machine-translated data sets. So also someone could ask me, why can't you just take the English training data and use Google Translate to translate it to different languages? Because this is also very common what we see. But there are 2-3 issues in it. First, if we are talking about Indian politics, it's actually mentioned in Hindi, but you will not find much of it present in English. And similarly, if there are politics which are happening in China, you would mostly find it in documents which are mentioned in Chinese. So if you actually keep on translating English to different languages, mostly you'll find the majority of your documents are talking about things which are happening in the USA, because a majority of English corpora is all West dominated and USA based dominated. So if you just translate them, you lose out on your own culture and your own rich information which your language provides basically. So that's why machine translation works fine, but ideally in our way where we generate questions using a large language model, you can capture language specific topics and language specific ideas. And the third is, in our data set, we also cover 20 different Indian languages. So we do cover Hindi, Tamil, Punjabi, Bengali, Marathi, Kannada, and so on and so forth. Also, we do cover some very low resource languages, which even I didn't know. So I'm not sure if you would have heard the language known as Boro. How many of you had heard this language before? One person, two. Yeah, so it's not surprising. I was also one of you. So there are apparently so many languages within India that even we are not aware of. Yeah, so the good part about our data set which we created through LLM is that we gave a lot of training pairs. So previously existing training data sets only contained up to a maximum of maybe let's say 750K training pairs. We increased it to 28 million actually. So that's about 37 times more than what was there existing. So here are some examples. So first one is cross-lingual training pair. So along with monolingual, which I talked about in MIRACL, we also have cross-lingual. So in cross-lingual, the passage can be in English. So in this example, you can see the passage talks about Menlo Park in New Jersey. And the query which we generated was actually in Chinese. So you can also do these kind of things in LLM, where you ask it to generate a query in a different language, but it's actually, if you translate it, so where did Thomas Edison invent the phonograph? And you find that, it's somewhere there, like, it actually got invented in Menlo Park. So, the answer is present within the passage. And along with that, we also gave out monolingual training pairs. So monolingual training pairs, like I mentioned, both the passage and the query in the same language. So in this example, you see the passage is also in Spanish, and the query which we generated using ChatGPT or a large language model was also in the same language, Spanish. So our main research goal, or what we wanted to see was in this project was, can we get rid of the human labeled training data at all? Because human labeled training data is very expensive. And for example, I did this with 33 languages. Now, let's say MIRACL was only for 18 language. Now, today I want to add a new language. So for the new language, I have to go through the whole existing annotation setup. First, I would need to find speakers who speak that language. I would need to hire them. I would need to supervise them for 4 months, and then I can extend that language. So you can see this process is very expensive to extend to new languages. So that's why my research was focusing on is whether I can only use synthetic training data to train the models, and absolutely not have any sort of human labeled training data there. So you can see basically all these models above the SwimX. So SwimX was the model which we proposed, which only fine-tuned on synthetic data. So we evaluated on 3 different benchmarks. If you're interested, you can look into the benchmark, but all of them have different question answers in different languages. So I mentioned them, few of them have 7 languages, others included 18. And Extreme Up is a good data set which focuses only on Indian languages actually. So if you see for these benchmarks, so we take the SwimX model, which is trained on our own data set, SwimIR, and actually it outperforms the previous models. So all the above models are actually trained using some human labeled training data. And you can see that our models are able to outperform them in at least 2 of the 3 benchmarks, so which is pretty good. And in one of them it doesn't outperform, which actually shows that there is future scope to actually improve the kind of training data which I generated. Lastly, what we found was interesting in our paper, one was we did a cost comparison. So in this cost comparison, the blue line which you can see is basically our synthetic models. And on the y-axis, you have the performance improvement, which is mentioned as a relative term. And on the x-axis, you have the annotation cost. So if you are taking the human label data, so that's mentioned in the green point there. So for the green point, you actually got only 15,000 pairs, but you spend about 15K USD in that. But now with the synthetic training generation technique, you can get up to 250K pairs, and using those 250K pairs, your performance kind of outperforms the existing supervised model, but you only did all of this in probably 1K or 1.5K USD. So in terms of cost, it's much more efficient. So that's one of the points there. The second one is that if you see this right hand side, so it's a very complex heat map. But what I try to evaluate here is some Indic language transfers. So to give an example is basically I try to train a model only on Hindi, and now I see whether does the Hindi model perform well on Kannada or Marathi, because Kannada and Marathi are kind of similar, or maybe Marathi is similar to Hindi. So these are things which I actually try to evaluate. And we find some interesting observations here. So there are few languages such as Boro, Manipuri, Odia. So these three languages, actually we found that the cross-lingual transfer doesn't work so well. So there are certain reasons for this. One is I feel like Boro is such a low resource language. We didn't have training data, or the quality of the training data was not so great. And on the other hand, you will find some languages such as mostly Kannada or Hindi, which transfer well to other languages. So Hindi, if you train a model on Hindi, you can do pretty well on other Indian languages, even though you don't have training data for those languages. Yep. Okay. So yeah, let's now talk about some open research problems, and I would then conclude my talk today. So first question is, I talked about these existing models and how they are basically, these existing benchmarks were saturated. Coming now in 2023, you may ask the benchmark which I proposed, maybe that has also gotten saturated. And that is true. Because, in the research community, people are always coming ways to outperform someone else's model. And what they end up doing is they end up even overfitting on our BEIR benchmark as well, the benchmark which we proposed. And how they do it is now they know which domains are covered. So they know COVID-19 is covered. So they will train on COVID-19. And they will train on all these different domains. And then they will claim that, their model is still zero shot, which is wrong, because you have now seen the terms already before. So this is one of the active problems, like, retrieval models are getting better and better, but, maybe they're also overfitting, and we have a false sense of progress here. Lastly, more hot topic, RAG. I'm sure someone of you or many of you would have heard about it. So in RAG, we have an active issue about hallucination. I'm sure many of you would have heard about hallucination. So what does hallucination mean? There are many meanings, but the one which we try to focus is that we had a lot of passages actually. So when we did MIRACL, we gave annotator some passages, right? You can imagine the annotator might have generated some questions which are unanswerable. So for example, to give you a very bad example, like, where will the FIFA World Cup be hosted in 2038? No one knows that yet, but probably they might in some time. So this is an unanswerable question. So what we do is we get the passages which are more relevant to this question. We get top 10 passages, we give the question and we give the passages to a large language model. And then we ask the language model, do you think the answer is present within the passages or not? And if the model says yes, for this case, that means it's a hallucination, because, in reality, the answer is not present, but you are assuming that the answer is present within the passages. So this is some of the, areas which currently research is delving into, like in RAG, and how you can make the hallucinations in large language models less. And in order to do this, we created a data set known as the MIRACL. So if you're more interested, you can look into the paper. But it's a data set in which you can evaluate these hallucinations in a better way. And on top of that, we are kind of hosting a Trek RAG challenge in 2024, which I encourage all of you to definitely participate. In the Trek RAG challenge, what we would give is, we would give you similarly some questions. And we would ask you then to build your own RAG setup. So you can do ChatGPT, you can do Llama, you can do Mistral. So there are many options. Take whichever one you like. And you give us back the most relevant passages which you find using a RAG system, or a output or a summary of the answer. So these two things you give us back, and then we would basically put you in the leaderboard based upon where you have performed or not. So this will be good for you because your model and your technique will get recognition. This will be good for us because we would get some gold labels which you would give us, because we didn't have to search through these passages. Your good model gave it to us. So this is how usually the tracks work. Like, many people participate. and using that participation, they create a better and better version of the data set each and every year. So yeah, if you're interested in participating, please, we haven't officially posted anything yet, but throughout the year, we will post it, and feel free to participate. So yeah, to conclude, actually, we talked about many things, and this is a very generic conclusion, but I think so it's most important. First is that often you would find limitations in models during evaluation and on benchmarks, and these actually help accelerate better model progress. So to give you an example, before the BEIR benchmark was introduced, no one knew about model generalization. People were more focused upon MS Marco and being 0.1 better on that. But after we introduced BEIR benchmark, now if you see at least any major model in IR space, if they're releasing, they are evaluating on the BEIR benchmark, which for us is a big win, because we are making people evaluate on more and more data sets, so that you know where your model is good on, and you also know where your model is bad on. Another thing is, you should, like I mentioned, you should always evaluate your models from a practical point of view. So try to include challenging tasks. Like, what we try to handle is very low resource languages such as Boro. So these languages are very challenging actually to do well. Third is, what I always recommend people is, do not always chase SOTA leaderboard improvement. You'll find people who are actively trying to break the leaderboard. But remember that your model may stay on the leaderboard for maybe 1 week, but eventually will get replaced. So what really stays in the research community is an technique, which further research can adopt your technique, or a benchmark, which further people can adopt it and keep on using it. If you focus on just getting the better model on the leaderboard, these days the research area has exploded so much, maybe within 1 or 2 days, there's a new model which outperforms yours. So it's going to be very hard then. And lastly, what I want to say is, there is no free lunch. In a way, there is no set technique actually to improve model and its performance. It's a very hit and trial error or method. There are many ways you can improve it. Today, what I talked about is mostly in the area of generating some synthetic data, and you can use that to improve your model. But there are other ways which other researchers do. One is they improve the scale. Like, instead of taking like a very small bird-based model, these days they've been using LLMs actually to do retrieval. So they do perform well, but they have their own, sort of negatives, because it's a very huge model, your latencies and the speed will become low. So yeah, the idea is that there is no free lunch. So you make sure you try and hit and try many things and see which one works for you. Yeah, and with that, I would like to thank you all for listening my talk. And if you have any questions, please ask.
So, like as you said, like you can't use Google Translate to bias towards the West side or like whatever the reasons are. But suppose I'm trying to make a AI system for building a chatbot for suppose COVID-19, and I have the documents in English only, and I am trying to retrieve it in a language in Hindi. So, like, what is the logistics behind the multilingual information retrieval? As you said, the translation to Google would not be retrieved. So, like, what are the logistics behind it?
I didn't get the question. So logistics behind the cross-lingual retrieval task in general? Like, okay.
It's like what gets translated, the prompt gets translated again and again. What is the backend behind the multilingual IR? Like, suppose the use case of having data in English and retrieving it.
Okay, very good question. I'd like to clarify this. So first of all, there is no translation involved. We are actually learning to map these languages in the same embedding space. So to give an example, let's say my name is Nandan Thakur, and in Hindi it will be Mera naam Nandan Thakur hai. So these both words, although they're in different languages, they will be mapped close to each other in the embedding space. And we are learning these mappings. So our embedding space originally was English only, But right now it's becoming multilingual because the mapping between my name and in Hindi, they both are coming closer to each other. So in typically how we learn these cross-lingual models or multilingual retrieval models is that you will try to map the English query very closer to the passages in different languages.
Also, one more question.
Yeah.
Suppose like we are trying to make a chatbot for again COVID-19.
Yeah.
And I have like tried different models. I have made a database, and I'm trying to get evaluation metric. So suppose one of my models are like outperforming very well. So do I need to check, as I said, like the BEIR benchmarking? So do I need to check it for like the whole BEIR benchmarking, or like if I'm getting good results on a specific use case, for example, and I don't like that is a continuous deployment, and again the new documents are being added into it. So that model I think which is good for a specific use case. So like will that be a good practice to just leave it there, or maybe check benchmarking for different use cases, as you said in the BEIR vice or BEIR evaluation, or like maybe checking different models. Like.
Yeah, a good question. So the short answer to this is depends upon you and your task. So if you are building only specific for that task and your company or your project only cares about that task, that's okay. But what we were trying to tackle in our research problem is to give you a model which works for anything or which works out of box for your domain. So that's why we try to evaluate on different domains. However, if you're creating a domain specific model, that's fine. You can probably try to evaluate on few different other data sets which are within your domain just to see whether you're not overfitting. So that will be a thing which I would recommend.
It's like also like as you said, suppose a generalized model and a model with specific use case and implementing a RAG and having good evaluation metrics. So like what is the evaluation between both the individual entities, like one with it having a generalized model and one with implementing a RAG in specific use case having good evaluation metrics. So like can that be compared or not?
Again, good question. I think so. It can be compared. Of course, I immediately think to my mind, probably the generic model won't do so well, but that will also push me to make a better generic model. So maybe for your use case, see what works well for you. But a generic model is often very useful for many organizations because they don't want to spend time training the model. Many people who are not us, who don't know much about the research, so they only care about the end product. So they really don't care what you do. So for them, ease of getting the model and how to use it is more important. So for them, probably a generic model suits their purpose. But for people who really want to drill down and want to get the best results, probably something specific for their own use case works well. Yeah, hope it helps. Yeah.
Okay, so we'll take a question. So firstly, let me thank Nandan, and I request you all to definitely thank him for.
Thank you.
Secondly, many of you are still looking for projects, so I announce at least after this. So whatever the challenge Nandan has mentioned, you are free to participate in that challenge as part of your course project, right? So if any of you interested, of course, Nandan can provide you more details, and you can take that as a course project for your course. So that is second thing. Third thing, I have a train to catch, so I will leave. But I appreciate you all to just feel free to ask as many questions that you have. I hope you